Okay, so there on the left, you see kind of that house-looking figure there. Obviously, that is not a cylinder. It is not a square pyramid or anything like that, but it is made up of a square prism with a square pyramid on top of it. So you'll see in the diagram beside it, they have broken it into the two individual pieces, and they have put the measurements. They've transferred, I'm talking about for the pyramid, they have transferred the measurements from the base of this figure to the appropriate places in the square pyramid. So if we got to find the volume of the whole thing, we break it into the pieces that we can find the volume of, and then put those volumes together. So the volume of the square prism, remember yesterday what we did was we started by finding the area of the base. The base here is that square, 15 times 15. I believe that that's 225, but I don't want to take a chance. Yeah, 225. That is just the area of the base. We got to find the volume of the whole thing. So the volume is the area of the base times the height of that figure, which is 10. So the volume of this piece is 2,250 cubic inches. The volume of the pyramid, we start with the area of the base. That base is the same as the other base. It's a square. 15 times 15 is 225. Okay, the area of its base is the same as the area of the base of the prism because they're the same, right? All right, now the volume of a pyramid is 1/3 times the volume of the prism. So the volume of the prism is the area of the base times the height. This height is 8. So definitely not going to try and do that one in my head. 1/3 times 225 times 8. 600. Turned out to be a prettier number than I thought it was going to be. Okay, so that's 600 cubic inches. How do we put those two numbers together? Add them, okay? Because we are adding the prism to the pyramid to make up that house-looking figure. So we do add those two volumes. So our volume of the composite is 2,850 cubic inches. So not too complex there. You just got to break it into the pieces and transfer the measurements where appropriate. If you look at example 2, it's a little bit different of a twist. Example 2 is not putting two shapes together. This composite over here on the left, we have taken out a piece in the middle. So what we have is, if you look at this as one solid piece, we have an entire cylinder, and then we have removed a cylinder from the middle to create that hole. So if we find the volume of the entire cylinder, volume of a cylinder, I'm just going to write in general terms first, pi r squared h. So the radius here is 9, and the height is 3. So we got 9 squared is 81. 81 times 3, I think, is 243. Yeah. Okay, so we've got 243 pi. We're going to leave it in terms of pi for the time being. 9 squared times 3 is what gave us the 243. And I stuck the pi on the end. Okay, we pulled the cylinder out, so let's find the volume of what we pulled out. Its radius is 5. It has the same height. So this one is 5 squared is 25. 25 times 3 is 75. So this one is 75 pi. Now, do we add those two numbers together? No, we're going to subtract because we took it out. If you take something out, you are subtracting. So if we subtract, now with it in terms of pi, since they both have pi, we can just do 243 minus 75. So we get 168 pi. Or if our answer choices are in decimal form, then we multiply the 168 times the pi. And we get 527.8. And these were cubic meters. Okay. Either of those is correct. It just depends. If it's free response like the quiz was, I accept either one. If it's multiple choice, you got to look at, is it in terms of pi or is it multiplied out? Okay? Questions about either of those? Okay. Let's do two more like this, and then I will turn you loose on practicing some. Let's look at the right side of the paper there. Number one, we have two square pyramids put together. Okay, how do I know that they're square pyramids? Well, this is the base, and based on the way it's labeled, it's got 2 feet pointing to both those sides. So that's a square, and it comes to a point, so it's a pyramid. Okay, so let's find the area of the base. So 2 times 2 is 4. That's the area of the base. So volume of a pyramid, you always start with 1/3 times the area of the base times what's the height of our pyramid? 1.75. Okay, we're just doing one of them. Okay, we don't need that entire height because we're just doing one of them right now. So 1/3 times 4 times 1.75. Oh, I don't like that number. Make that a fraction. 7/3 cubic feet. So that is one of our square pyramids. Are these two figures that we put together, are they the same? Are they identical? Okay, in this case, they are identical. They have the same heights. They have the same length and width. So they are identical, so we can either do 7/3 plus 7/3, or what could we do? Multiply by 2. So we get 14/3 cubic feet for the entire figure. All right, the problem or the diagram in number 2 is illustrating that we have taken out that cylinder from that rectangular prism. So let's find the volume of the rectangular prism first. So the rectangular prism volume, area of the base times the height, or length times width times height. So 10 times 14 times 12. (1,680 cubic inches is the volume of the rectangular prism. We've got a cylinder in there as well. So the cylinder volume is pi times the radius. Are we given the radius? Is that the radius or the diameter? Radius. Okay, it's from the center to the outside of the circle, so that is a radius. So we go with the 2 squared times, what's the height of our cylinder? 12. It's the same as the height of this prism. Transfer that right here to the inside. So we've got 48 pi. We're taking it out, so we subtract. Now, since the 1680 did not have a pi, it was not in terms of pi, I do need to subtract the entire 48 pi to get my answer of 1,529.8. 2.